The problem, what stops a hijacked AI agent from reaching your core system? The hard truth is, if your security sits in the user space, the answer is nothing. An AI agent with valid credential gets prompt injected. It tries to move money it should not. Most security stacks would let the request through. The credentials are real. Here is what we do instead. Live on two machines, 90 seconds. One of the node, we are running the AI gateway, deterministic execution gateway with IP 10.10.10.1. We are running the AI deterministic execution gateway on this node. In the second terminal, we are running the protected system, the mocking ledger, the banking ledger, which is mocked here. And in the next terminal, we are running the management and control plane. The final terminal, we are running the telemetry. Meanwhile, we'll run the second node, will the traffic generator node. The traffic generator node is running in the IP 10.10.10.2. We'll rerun the telemetry here. We are rerunning the gateway. So all the packets telemetry pass and dropped are zero. Right now we have the passed, dropped, and banned IPs zero in the telemetry. So as discussed, we have three layers: the brain AI triage, which is N89, Zeek, and Olama; the control plane, which consists of OPA and the Spire agent, SPIFY agent, and we have the data plane XDP in the Linux kernel where enforcement actually happens. This is the gateway attached in the native driver mode as we have seen earlier. We have the gateway running in 10.10.1 IP successfully attached in the native driver model. And we have the traffic node running in 10.10.2 node. We are moving to the next scenario, the legitimate action. We are injecting a from the traffic node, we are injecting a authorized agent tool call. This is a legitimate agent, authorized the transfer, approved amount. The control plane checks it against the policy and it admits it, and the traffic reaches the ledger. It's a normal traffic flow. As you could see in the gateway, the control plane takes the decision of admissibility against the OPA, passing the action parameter, identity, and other parameters, action parameters. So it is passed the verdict of admissibility, admitted with the action transferred. The source IP is passed on to the kernel. The transaction is logged in the ledger with the SHA-256. We could see enforcement admitted. So the banking ledger should get this transaction. Yes, the banking ledger has got the transaction successfully, which is logged here. And we have the telemetry. Packets are passed. There is no zero packets. We are moving to the next scenario, the legitimate, the attack and the automatic ban. In this scenario, we will pass a malicious packet from the traffic generator node. We are passing a malicious tool call from the agent. Now the same agent is hijacked. It tries to transfer an unapproved amount. The control plane judges it as inadmissible, and watch what happens. No human in the loop. The gateway writes a ban straight into the kernel. The source is now blocked in the silicon. See, as you could see, we are injecting a malicious packet from the simulated IP 10.10.99. So here, once the packet reaches the control plane identifies that it has a threat and pass the verdict as inadmissible, enforces inadmissible, and passes on to the kernel. The kernel now blocks the source IP. The silicon, it's banned in the silicon. The source in the simulated source IP 10.10.99 is banned in the silicon. The XDP drops all further packets. The enforcement happens here, and the transaction is logged as a SHA-256 ledger entry. So as you could see, there is no packet reaching the mock ledger. The system is protected. The ledger banking system is protected here. So we are moving to the next scenario, the wire speed proof. Here is the difference between a control that is inconvenient and one that is impossible. I will flood the gateway from the traffic generator node. You could see from the telemetry there is zero packets dropped here. So once we start injecting, flooding the gateway from the traffic generator tool, from the band IP, you could see the gateway bans all the or drops all the packets which are getting flooded in the gateway. The dropped counter is getting incremented in the gateway. The ban is still valid. The data plane ban source IP is still valid. The kernel enforces the packet drop, the admissibility is already inadmissible from the control plane. So all the packets are getting dropped in the deterministic execution gateway. No packet reaches the protected system banking ledger, and you could see the telemetry is getting incremented. The drop packet is getting incremented. The band IP is, we have two band IPs there, and we are moving to the final scenario, the resilience close. And the part I'm most proud of is this one. I will kill the brain entirely. The A layer is now down. The kernel keeps enforcing the ban holds. Legitimate traffic still flows. Enforcement that survives the failure of everything above it. That's the floor most stacks don't have. I'm stopping the Olama here. As you could see from the status, the Olama is killed, but still the packets are getting flooded from the traffic generator tool. But right now, as you could see, the drop counter is getting incremented. The ban is still valid in the gateway. Zero packet reaches the protected system, which is the banking ledger here, and you have the telemetry incremented. So finally, we have Aegis Forge kernel enforced, Aegis Forge kernel enforced action control for AI agents, decision in the control plane, enforcement in the kernel. When a compromised agent can't reach it, if you are working on agent security, I would value your read. Let's talk. Founder at aegisforge.in. Thank you.